All right, welcome everyone. Thanks for joining. When I submitted this session to the conference, I had to decide if I should submit it to the analytics track or to the data track. And I decided that it absolutely belongs in the analytics track. And the reason is because the way that you structure your data changes from question to question. So imagine you have patient data and you want to assign a risk factor to each patient based on demographic data and diagnoses. You need your data at a patient level of detail to do that. Whereas then suppose your next question is, have they been prescribed a certain medication before or after diagnoses? That requires you to reshape your data to create a historical view. My partner is a doctor, and so he does a lot of research and audits. For example, he's done an audit to make sure that cardiologists are actually prescribing the correct medication according to the guidelines. He also reruns trials that pharmaceutical companies have done to make sure that the pharmaceutical companies didn't introduce any selection bias in their results. So obviously this amount of analysis is something that Tableau is very great at accomplishing. And his preferred method in working with this data is natural language processing. And so that is where he asks a question, and I process the question, and then a viz just magically appears. So the first project that he had, I was like, this is amazing, like we're bonding, our fields are uniting, so excited to help. And then a second project comes along, and I was like, sure, I'll help you with this. And then a third project comes along, and I'm like, you know, like I do have a life outside Tableau. And then by the time the fourth project comes along, I was like, okay, seriously, data analysis is clearly a fundamental part of your job. You're just gonna have to learn how to do this yourself. It's easy, anybody can use Tableau. So he looks at me and he's like, okay, well, why don't you get your UK driver's license? It's easy and anybody can drive. So I'm like, oh, there's no way I'm gonna win this argument. It's just not gonna happen. Let's continue. I mean, the man is busy saving lives while I sit behind a computer dragging things all day. So we continued. However, this past weekend, everything changed because I left the country. And so on Sunday at about 3 p.m., my phone goes ding, and I get a message, and it has this picture from my partner. He's analyzing the rate of bleeding in different drugs, and then the color is showing the breakdown by the type of bleed. So a brain hemorrhage is much more severe than a GI bleed, which is much more severe than a nosebleed. And this is the message. He's so excited. I'm almost there. And about 5 minutes later, ding, I get this image from him, and he managed to figure it out. And he's so proud, and I was so proud too. This is amazing. So what's wrong with the first viz? Just shout it out. We're all friends here. You can't compare, yeah. The reason is he's not using measure names and measure values. He's got measure names, but two separate measures. I remember when I first started learning Tableau about over 3 years ago, I found measure names and measure values very confusing as well. And if you mess around with it enough, you'll get there, but you don't necessarily understand why. And then when I finally realized one day that measure names and measure values behave in a way to unpivot your data source in a sense. And then it made sense, and then from there, it's easy once you build this mental model of what's happening with the data. And so as you're on this path from your first viz to complete mastery, part of the process of getting there is really being able to build in your mind a good mental model of not just what's happening in your visualization, but what's actually happening in your data. And that's what this session is about. So in terms of the learning objectives, what I want you guys to get out of this session is an understanding of when to use table calculations versus level of detail expressions and versus data prep. Sometimes it's better to do things outside of Tableau. The second objective is to understand how to structure your data for historical versus point-in-time analysis. So point in time could be, of the patients on my ward right now, how many of them are new this week, how many of them are carried over from last week, and how many have been readmitted. Historical analysis would be, how are those cohorts changing in time? And then finally, how to analyze rolling changing dimensions over time. So rather than just defining your cohorts on a weekly basis, you might want to define them on a rolling 3-week basis. All right, so let's get started with our first example. Are these things that people care about learning? Awesome, okay, that's great. Okay, so let's start with our first example. So this is using our famous Superstore data. And what we're trying to identify is roughly the distribution of frequency of purchasing. So how much time elapses between customers making purchases. So what this is showing you is that there are 135 customers who make repeat purchases within 90 days as a median metric. And then the cumulative function is showing you that 94% of customers make repeat purchases within 420 days. All right, so let's look at how we would do this. If we start off just looking at our customers and our order dates, what we need to find is the amount of time that elapses between these orders. So I'm going to drag in a table calc here. What it does is it just looks up the next value of the order date and subtracts the current value. And I'm partitioning this by customer. The next thing we want to look at is taking the median of that result. So this is looking at a window median of the time, and then that gives you the value, again, partitioned by customer. And now because we want to create a histogram, we need to break this into 30-day bins. So all this is doing is rounding down the median to the nearest multiple of 30. Now you'll see that these medians are a customer level metric, but they're being repeated across the days. So we don't need to keep all the repeated values. We just need to keep one value. It can be any one, but we'll just keep one. So I'm going to reduce the size of the data set, and now we can go and build that visualization. All right, drop that down, and then we can bring in our number of records. And this is giving us, if I just split this up a bit, this is giving us exactly that distribution that we wanted to see. So this can be done with table calculations. Anything can be done with table calculations. But is this the best way? Who says yes? That was the correct answer. Well done. So the reason is because we have to keep the customer and the date in the visualization, because that is what is defining the table upon which we are applying the table calculation. So that means if you have lots of customers, you're going to be returning many, many, many marks to Tableau. So while it can be done, this is definitely not the best way. All right, so this is actually the kind of problem that we invented level of detail expressions for, where the level of detail of your calculation has to occur at a lower level than the level of detail of your visualization. So who thinks, should we try and solve this with level of detail expressions? Can it be done? Shout it out. Yes, okay. Let's look at why it can't. All right, so we went through that. Okay, so I'm going to simplify the example. Rather than looking at the amount of time that is elapsed between every single purchase a customer makes, we're going to look at the amount of time that elapses between the first and the second purchase. So in this table here, I've got customers and order dates. And so the first thing I'm going to do, so the scope of the question here is, what's the amount of time between the first and second purchase? So I can look for the minimum order date per customer, and then return that as a customer level metric, because it's a customer level LOD expression. That repeats the first purchase date across everything for that customer. I then want to find the second purchase date. So I need to find the minimum of everything except the first date. So then I'm going to do a row level calculation that says, if the order date is equal to the first purchase date, then return null. Otherwise, if the order date is not equal to the first purchase date, then return the order date. And so that gives you everything following the first purchase date. We can then say, what is the minimum of this new column? And that gives us the second purchase date, again, as a customer level metric. We can then do a row level calculation that takes the difference between the second and the first purchase date, and that tells us the amount of time that it took them to make their first repeat purchase. So level of detail are a great solution when you have a finite number of periods that you want to compare, first and second or first and last. But in the case that we're looking at, we want to look at every interval of time between every single order date. So to expand this solution, to look at an unbounded, indefinite number of repeat purchases, we would have to create this calculation like 10, 20 times. So that's not the right way of approaching this problem. Yeah, with table calcs, again, just to put like a really clear picture in your mind, you'll see with the LOD expressions, everything's returned at a customer. There's only one value returned per customer. Whereas with the table calc, we're returning multiple values per customer. And that's the fundamental difference between how LODs behave versus table calculations. Does that make sense? Say it louder. Does that make sense? Awesome. Okay, so now let's look at our remaining options. So table calcs is not a good solution, though it works. LODs won't work at all. So the next option is to do something in the data. All right. So what we're going to do is create two tables. A table at the customer and order level, and what we want to do is rank the order dates in ascending order. I'm going to create a second table, and the difference here is that I'm subtracting one from the rank. And what we really want is to be able to pull the next order date into the prior column so that we have an actual column for next order date. So what you can do with this is join these two tables on customer is equal to customer and rank is equal to rank minus 1. So now it's pulling up the rank that was the second order date into the first row and matching them. So you can see now that we've essentially created an offset that lifts all of the order dates one row up. So this is the best way of solving this problem, and now I'm going to show you, if you don't know how to write SQL, how you can use Tableau to generate the SQL for you. That's how I don't really write SQL at all either, but I have found that Tableau is like the most productive way of learning SQL because you can just make it generate queries for you. So what I'm going to do here is I've created a visualization that contains the level of detail of those tables that we need. So the customer, the order date, and sales. So what we can do is turn on the performance recording, and I'm just going to replace the data source so that it triggers a new query to run. And the performance recorder is going to capture that query, and then we can use it in our connection without actually having to write a bunch of custom SQL. So now I'm going to stop the performance recording. That's going to pull up a workbook that tells us a whole bunch of useful things about this, but most importantly, it gives us the query. Did I hit stop? It's not interesting. Okay, there's no, oh, there it comes. All right, so we can grab the query. There it is. You just click on executing query, grab that query, copy it, come back to Tableau, and then we can create this as a new custom SQL connection in our data source. So you don't really need to know what it does, just that it works. The one modification that we do need to make to this is to add that rank calculation into the SQL. So the rank in SQL actually is sort of similar to syntax to our rank functions. We're saying partition by customer and then order them by date. So now we'll see that this gives us exactly the table that we need. So I'm going to just copy this again. And we need to join this table to itself on customer, and rank is equal to rank minus 1. So just paste it in here, subtract 1, and now we can join those two tables on customer ID and rank is equal to rank. Just one other thing I'm going to do to make this a bit easier to understand is rename this as next order date. And so what you'll see here is that if I zoom in, the order date in this, the order date in this row is exactly the same as the order date here. It's been pulled into the prior row. So that's giving us exactly what we want. Okay, so going to our viz. Now it's really easy to create this analysis. Another point I should mention here as a best practice, when you're using custom SQL, it's a good idea to extract the data. Otherwise, we run that whole query for every single thing you drag and drop. If you want to use a live connection, do all of this through materialized views in the database. So now we want to create a calculated field here that finds the duration. And this is just going to be a row-level calc. It's no longer a table calc, because those are now offset in the same row. So we've got our duration, and then we want to find the median of that duration at a customer level. So now we can use a level of detail expression to say, per customer, give me the median of the duration. Because there's multiple records per customer as they make multiple purchases. So this is the median. And now we can turn that duration into bins, 30-day bins. And then it's very simple to build our histogram. We look at the number of customers and split out by our bins. I did something wrong. What did I do wrong? I made the bins on the wrong field. So you make the bins on the median field. And there we go. We've got our nice histogram. So much easier, much more robust, much more performant, works on large volumes of data. Cool? Awesome. Okay, so our next example here is looking at cohort analysis. What we want to see is how many customers are new. So it's our first time purchasing in a selected month. Here we're looking at November 2012. How many are existing? So that means they made a purchase in October 2012. How many are reacquired? That means that they made a purchase at some point in the past, didn't buy in October, and then bought in November. And how many are lost? So that means they bought in October, but they didn't buy in November. Who needs to do this kind of analysis? A lot of people, yes. Okay, so, and you'll see that we can watch kind of how this evolves from month to month, from January to February, and how many are carried over into the next month. So how do we do this analysis? So I'm starting out here with a viz, again, looking at customers and looking at dates and then looking at their sales. What I need to do is create two measures, one for the sales in the selected month and then one for the sales in the prior month. And that allows us to make the comparison to find those four different conditions. So the sales for the current month, this is basically just a level of detail expression. And I should say this is being recorded and you'll have the workbooks. So you'll have all of this detail later if you need to rebuild it on your own data source. So we're just comparing the month to the parameter. And we're saying when those are equal, return the sales at a customer level. So here, these are equal and it's returning the $35 at a customer level. The prior month calc then does pretty much exactly the same, but we're just looking at comparing it to 1 month before. And so here we can see that there's no purchase in April, so it's 0 for this particular customer. I should also say that the reason we're doing these as level of detail expressions is because if they were row level calcs, the results would be in different rows, and you couldn't then compare them. So by using an LOD, it replicates that value across all rows, which is what makes the comparison between periods possible. So finally, the cohort calc is then just checking those four conditions. So if the month that we've picked is the first is the first purchase date for that customer, then we know that they're new. If the sales for the prior month is positive and the sales for the current month is 0, then we know that they're lost. If the sales for the prior month is 0, but positive for the current month, we know that they're reacquired. And the reason we know they're reacquired is because we've already checked the condition of whether they're new. So it's important that you order the statements in this way. And then finally, if both are positive, then it means they were carried over from the prior month and they're existing customers. So with this, it's very simple then to just go and build our visualization that shows us by different cohorts how many customers we have. Cool? Awesome. So now we want to look at another metric. So we don't want to just see the current month cohorts, but we want to see how these are changing on a rolling 3-month basis. Who here does a lot of analysis of rolling periods? Like everyone. Okay. So yeah, what this is showing you here, if we focus in on the new customers, is we are looking back 3 months from May 2012. So we're looking between March and May. And we're saying of the customers who bought, if a customer bought for the first time between March and May, we're going to consider them a new customer. If they didn't buy between March and May, but they bought between December and February, then they're lost. So we're kind of redefining the period over which we're going to be making that comparison. Now, the calculation for this, for creating these rolling cohorts is almost identical. There's not anything too different from the other example I just showed you, except that we're just comparing this to a range in time. So we're saying return the sales for any months that occur between 2 months before the selected month and up to the selected month. We're then doing the same thing for the prior rolling period and saying anything that occurs between 3 to 6 months before the selected month. The one difference with our cohort calc is the way that we define new customers as well. The other conditions are exactly the same. So with new customers, we define them as new if the first purchase month occurs between 2 months before the selected date and the current date. Okay, so that's how you end up with this visualization. But now what we wanted to see is those two metrics side by side to each other. And this is the point at which you go, okay, let me drag in my other cohort. And then what it does is that the computer does exactly what you told it to do, but it's not what you want. How often does that happen? So it's splitting these up and showing of those who were new in the last rolling 3 months, how many were actually new within the current month. So it's still useful, it's just not what you want. And so what makes this particularly challenging here is the fact that we have 2 dimensions and 1 measure, but the viz that we want has 1 dimension and 2 measures. So how do we work that out? Well, it turns out that you can solve this with a little blending trick. So if I just exclude these null values here, what we can do is duplicate the data source and then set up the relationships so that the cohort is equal to the rolling cohort in the secondary data source. And then from that, we can grab the number of customers in the secondary data source, do a count distinct of those, and then that will give us a comparison between months and rolling 3 months. So this is just a generally useful trick to know whenever you need to put multiple dimensions on one view, but you want them to be like a single dimension. So another example of this would be if you want to compare acquisition channels to regular sales channels and see revenue from both of those on a single chart. Sound good? Good trick? All right, so now let's kick this up a notch. Let's do something really cool. So with the parameter, we were only ever able to look at one single slice in time. And it's really hard to see how these cohorts are actually evolving over time. And so you'll see on the viz on the right here I'm labeling the points for the current month, and you'll see that this is giving us 71 lost customers, 51 reacquired, 12 new, and 6 existing. So it's giving us the exact same numbers, but in a much more useful view that puts it in the context of, is that within a normal range? So this requires a completely different data structure to the transactional data that we have. And let's think about why. So I have an entire dimension in here called lost. When a customer doesn't make a purchase, there's no record written into your transactional database to say that that customer is lost. You just infer that they're lost on the basis of the absence of a record. However, it's very difficult for a visualization to be drawn on the absence of a record. So this is a case where we actually need to create data for every single month and for every single customer, so we can say in that month, were they lost, were they new, were they reacquired, or were they none of the above? So let me just jump back in to PowerPoint here and talk you through how we're going to do that. Okay, so we want to create, I'm calling this a scaffold table. It's a table that has every combination of months, of customers, and every combination of months. I've also added in a prior period column, and the reason for that is because what we learned from example 1 is that it can be very useful to have a prior or next period column in your data source when you want to compare multiple periods. So we're then going to create a second table, and this is going to give you your sales aggregated by date and by customer. And we're going to join those on customer and period. And so what happens to your sales table, the little one on the right, is that it gets padded. And so we end up generating a bunch of missing records for all of the months in which the customer didn't actually make a purchase. And so the next thing we have to do now is add a column next to that tells us what the prior period sales were. Because what we've seen from that cohort calculation is we're always doing a row level calc of current period versus prior period. So we're going to do that in the data source because we know that lookups are not good at that, and we know that LODs can only do this for a finite number of periods of time. So then we take our resulting table and we grab our orders table again, and then we join it to this resulting table. But in this case, we join it on customer again, but on period is equal to the prior period. And so what that does is you'll see here January in the orders table is being mapped to February in our master table. And so what that does essentially is it offsets the sales of the prior period into the next row through that join. So this is the resulting table from all of those operations. The only columns we really care about are the customers, the period, the sales, and the prior sales. And that's all we need to be able to do this cohort analysis. The others can be discarded. They just exist for the sake of defining the joins. Make sense? Okay, so again, this is creating a lot of tables, and we're going to have to write a lot of SQL, and we don't like doing that. So we're going to create another query generator sheet, as I call it. So I know that for that scaffold table, I need to select all months with the prior month, and then join that to a table with all customers, do a product join, and then that gives me that scaffold table. So here you can create a calculation in Tableau that just gives you your prior month, and run the performance recording, and it's going to output this query here that we don't need to worry about how it works. It just works. Yay! So let me go and add this to the data source. So the first thing we're going to do is look at our different months. So that's generating that query from the performance recording. And if we look at this table, it's giving us now 48 rows, one per month, and this is across 4 years of data. So let me just rename this table here, month. And then what we want to do is join in the customers so that we essentially take this and union it to itself for as many times as we have customers. So I'm going to create another one, and this one is customers. You can generate the SQL by dragging out, customer ID into the viz. Oh yeah, the one thing I have added is one as a key. I did that in both tables. By adding just a constant column in both tables, we can then join on that constant, and that produces a product join. Product join means we join every single record in table 1 with every single record in table 2. All right, so now we're going to join this on these key fields. And let me rename this to customer. And just so that you believe me, not this one, okay, let's look at the resulting data source. So we end up with all of our customers, and we end up with a record for every single month. So if I just drop that on the label, you'll see that we have a record for all of these different, for all combinations of everything. That's the way that you can generate that kind of table. So now we need to actually join in the orders data source. So you would take the same sheet as we used to generate the query for the bins. You take exactly the same query. And then join this in. What is it called? No, it is sales. All right, so you've seen this one before. This one's not new. And we want to join that on customer ID, and period is equal to the current period. So this is going to give us our current period sales. And we now need to do this again a second time to get the prior period sales. So let's just populate that. I'll call this prior sales so I don't get confused. And this is the same idea, joining on customers, except for now we are going to join on prior period is equal to period. And that's what is going to offset things into the correct rows. All right, so now let us look at this data. So we've got sales here. Let me remove that and let's label it with sales. Oopsie. And let's show this as a month. Discrete. Oh yes, okay, so what have I done wrong? I've done an inner join, so it's now removed all of the records. So the key here to make this work, let me call this prior sales as well. The key to make this work is to do left joins. The left join is what then generates the null records for sales. And that is the key to making all of this work. All right, so now you can see we have records for all of these. We've got sales, and then we've got prior sales as well. And that, you can see, takes the current sales and just shifts it into the next row. So now we're ready to calculate our cohorts. And the calculation for the cohorts is actually pretty much the same as the calculation that we used in the first example. So let me just bring this in here so that you can see. In fact, it is like exactly the same calculation as the cohorts from the first section. It's just that we now have data against which that calculation can operate. Whereas in the first example, we didn't have data for the calculation to operate against. So this is going to give us our cohort, and then we will be able to verify that it's doing the right thing if we drag this in here. So here it's new. Oh no, it's reacquired. Why are you reacquired? Lost. Am I missing? Let's do this like here. Reacquired, lost. Reacquired, lost. What have I done wrong? It should say, yes. I know why. My calc is wrong. Okay. Yes. Okay, so it's wrong because I'm looking at the minimum date of the current period, and the minimum date of the current period is always January. So what we really need to look at is the minimum date from the table where of the orders. So that is going to be the minimum period, which you will see if I bring this into the viz here, is going to be null for January. And so the minimum of that is going to be March. So this should fix everything. Yes, and now you'll see that the customer is new in March, reacquired in September. So it's doing the right thing. And with that, we can then go and build our viz that shows us the number of customers split across time by month. And, oh yes, and then by cohort, and then we have to exclude all of the nulls. And then that gives us exactly the view that we wanted. Now, another useful way of looking at this data, instead of just looking at it as lines, would be to actually show like, what customers do we have on a positive axis, and then what customers have we lost on a negative axis. So just to make this viz nice, we can say if the cohort is lost, then turn the number of customers around, and then otherwise just count the number of customers. And that's going to be our number of customers, and it's complaining because this is not aggregate, so let's make it aggregate. Okay, and so now, if we grab that, we can create something kind of cool like this that shows you, how many you're losing relative to how many you're gaining, which could be a useful way of visualizing that data. So let me see how many. Yeah, I think I have time for this. Okay. So this is just looking at customers defined on a monthly basis. But what if you wanted to compare this to cohorts defined on a quarterly basis or on an annual basis? Because this picture is a little bit sad. Let me modify the colors. So let's say that that's yellow, new is green, existing is blue. This picture paints, it just makes me a little bit upset, like we have no new customers. Maybe if we look at, or no existing customers. So maybe if we look at it at a higher level of detail, then this picture will be less sad. So how can we add in quarters and months? Essentially, we need to take what we've done and then replicate that for quarters, and then union it to this data source, and then replicate it again for years, and then union it to this data source. So I sneakily added in this period type field here, which is just month for the moment, but I want to create another period type for quarter and for year. So again, without having to learn SQL, I'm going to use my favorite method of copy paste. Okay, so if we go into Notepad here, I'm going to paste this in, and I'm going to use find and replace. And I'm going to replace all of the months with, sure, we'll do year. Okay? And then we're going to do the same thing, but for quarters. So we're going to find the quarters, and then replace that. No, sorry, we're going to find the months again, and replace that with quarters, and replace all. Okay, and so now we can grab this, we can union it to this, and then we can grab that and come back to our viz and union it to this thing here. No, that was always going to happen. What have I done wrong? I forgot a comma. And I forgot a comma there. Quarters, period type. Oh, wow. Okay, it worked. So now we have, for months, we've got 48 records. For quarters, we've got 16 records. And for years, we've got four little records here. So we've done it for our sort of scaffold table. But now we want to do the same thing for sales and prior sales. So you would just repeat. This is just like that repeated. And this again, let's do the same thing. And then that repeated again. No new tricks. And we've got our full data source. So now when we come back to our viz, you can see that we've got this by months, by quarters, by year. And one of the really nice features in version 10 that was added is these Mary Mako charts. So we can go and actually size these things accordingly. So what I'm doing here is just saying, look up the next one, take the difference from the current, use that to size the thing. Unless you're looking at the very last one, then we need to find, there's no other mark to look up, so just find the max date, diff that from your current thing, and then that will give you the size. So when we drop this thing on size, it gives you like kind of a cool, wait, what have I done? The month of current period. Do I need to make this discrete? Show missing value, nope, not that one. Make it discrete. Okay. Oh, fixed minimum size. Okay, something funny's happening. Let's pretend that worked. So, so this is what it would look like if it were to work. So now I've put this together in kind of an overall dashboard that gives you some level of insight into your customer churn, and also, not just how many customers are churning, but what's the value of those customers? Because if you're losing customers that spend no money, who cares? But if you lose your most valuable ones, then that's a problem. So the second viz here is showing us the customer churn. So customer churn is calculated by looking at lost customers divided by total customers in the prior period. And so what you see here, and I don't know if anyone's ever found this in Superstore, but I would love to see this on like real data, if there's real patterns in it. So here you can see that there's peaks in Q1 across all years in the churn relative to the prior quarter. And you can also see that there's just the lost customers seems to like increase throughout the year and then sort of like start over in Q2. And then the highlight action is showing you, each bubble is a month, and so it's showing you the number of customers versus the amount of sales that those customers spent in that month. The size of the bubble tells you what's the value per customer. So this is really bad because these bubbles are quite big, and it means that you're losing really high value customers while you're retaining few and also very low value customers. So this isn't the best picture for our Superstore data here. So now if you want to calculate the customer churn, we want to take this number and divide it by that number, essentially. So first thing we're going to do is split this one measure into two measures so that I've got one for lost customers and one for existing customers. So this is literally just saying if cohort equals lost, then count distinct customer. This one here is saying if cohort does not equal lost, then count customers. And so what we want to do is shift this whole thing here 1 year forward. So we can use a lookup table calc to do that. So we're going to look up these people. Whoop. If I can put it in the bracket in the right place, we're going to look up those people 1 year back. And so that just like shifts everything. So again, this is a very good use of table calcs because the data is in the viz. We're not trying to look up something at a customer level. We're looking it up at a year level. And so then finally, let me just simplify this. Our churn is then going to be the number of lost customers divided by this lookup function here. And let me just remove that. And you'll see that it's giving like 26%. It's giving us the right numbers. So we can remove these kind of intermediate ones and then turn it into a line and then look at it across all of our periods. And then we had to make this continuous, I think. And then it gives you sort of your churn rate by month, by quarter, by year in one nice comparable viz. What if we do that? Yeah, that's even better. That's kind of cool. Who needs to do this? Quite a few people. So like basically anybody with kind of a subscription business needs to do this kind of thing. So, all right. Moving on. Now we looked at how we can create a historical view when we're defining our cohorts on a monthly basis. But how can we do that for when the cohorts are defined on a rolling 3-month basis? So this is kind of exactly the same viz as you'd seen before, except for we're using our LOD expression that calculates the 3-month rolling average and then seeing how that evolves across time. So the curve is a lot more smoothed out, and you can see that there's sort of these inverse relationships here between lost and reacquired customers, which is kind of interesting. So how do we do this? I'm going to start out with our scaffold view. So this is just the view that gives you one record per month per customer, now that you know how to do that. So now let's think about how we can structure this to incorporate the rolling period of time. So what I want if I'm looking at June, I want to count all of the customers who made a purchase in June, May, or April. And then I want to compare them, those customers, I want to see if those same customers also made a purchase in March, February, or January, because we're defining the cohort on a rolling 3-month basis. So what that requires is for me to generate, for June, 3 more records for that customer so that we have a record for their June, May, and April sales that we can then group into that period. So again, we're creating new records, and we can do that by joining in another data source. So I'm actually going to join in the month table again. No, wait, it's not that one. It is, oh yes, let me show you what I'm going to join in. I lied. Okay, so what we need is a table that captures the current month and then the month of the prior period, which in this case is not 1 month ago, but 3 months ago. So you can create a date add calc, subtract 3. This is what you'll get, run the performance recording, get this query, and then we can go and stick it inside of this. So now, if I add in that rolling period of time, we're doing a product join again with this so that it replicates those months within every month, within every customer. So just to show you what this gives us as a table, if I refresh the query, how do I make you refresh? Maybe I'll drag in that, and that will do something. Query, okay. Tableau is being too smart about caching. There are 48 records behind this, but Tableau is caching it, so it's not showing you. Okay, so this is now our rolling periods. And then just like we did in the prior example, we've got to hang off of this table the orders for the current period and then the orders for the prior period. So this is not new. What I'm going to do here is just take sales and join that in. Wait, let me modify this to say, I'm going to call this order date because there's different date types happening and you can get confused easily. So this one is the order date. All right. And so we'll link that on customer, and then on order date is equal to the current period. So that gives us our sales. And again, as we learned, it must be a left join in order to keep all of the time periods where the customer didn't buy. And then repeat that for the prior month. So let me just rename this to prior sales. And then we want to join that on customer ID, and period is equal to the prior rolling period with a left join. So that's our prior sales. Okay, so now if we come back to this viz here, there, see, it did it. We've got 48 records now for each month for each customer because we've done that cross join with all of them. But we don't actually need to keep all 48 of them. We just need to keep 3. The 3 that are relative to the month that we are looking at. So if I drag in here the current rolling period, in, this will do, in July, I want to capture the sales that occurred in July 2014, where is that? In July 2014, June 2014, and May 2014. So those are the only 3 records that I need to keep. So now we are going to add in a filter. And the filter is essentially just doing some date logic to keep the current rolling period that's within 2 months of our baseline period that we're comparing against. I've also added in this condition here that prior sales and current sales both have to be positive. Or one of them has to be positive. Otherwise, we're just adding in records that are useless and exploding the data for no reason. So now, let us call this a filter. And then we can go and stick that on the data source. Okay. And so this has reduced the scope down to exactly what we want. So let's look now at the sales and the prior sales. And let me swap this around. So here what you can see, by the way, this is why Tableau is so useful for query building, because it doesn't make sense. You have to switch things around to understand what's happening. So it's really useful that you can do that. Okay, so now you can see that this person made a purchase for $832 in December, $36 in November, $89 in October. We're replicating that across all of the reference periods that would want to include that as part of their rolling history. And we see that they don't have any prior sales because they didn't buy in September, August, or July. And so now what we need to do is, if I put this back this way, is when I'm looking at December, I want to add up the sales that occurred over the rolling prior 3 months, which is going to be the sum of these things per customer. So now what we can do is create a level of detail expression where we fix to the customer level and the period the sum of sales. So that is going to give us the sales in the current period. And you will see if we drag this in, and this is why you want to extract this data, because everything I'm doing here is generating like wildly complicated queries. So now you'll see that that has summed up these two metrics to 957. So we have our amount in December. We need to do the same thing again for the prior periods. So let me just go in and then do that for prior period, and that gives us the sales prior period. All right, and then let me just extract this quickly. Okay, so when we look at our sales in the prior period, you will see that this 957 from December now shows up in the prior period of March, which is 3 months off from December, 3 months ahead of December. So you can see that it's doing the right thing. So now to calculate our cohorts, let me create another one. So we want to have our rolling 3-month cohorts. It's essentially the same logic again as what we used to calculate the cohorts in, oh, it's thinking. Please don't crash now. It's doing exactly the same calc as what we did in the first example and in the second example as well. And it doesn't like that sales prior period because I spelt it wrong. So let me go and just rename this correctly. Okay. So let's try that again. And this is going to give us our cohort. Right, so it's doing the same row level comparison of current period versus prior period. This is going to be easier to copy paste. Oh no, don't do this. There. Okay. Yeah, so the only difference between this one and the last one is, again, the new condition. So these ones are the same. Here we're just saying, instead of looking at the order date and if it's equal to the period, we're just adding this condition to check whether it's within the 3-month range of time. And that's the only difference in order to find the new customers on the rolling basis. So this is now our cohort. And then we can go and build our viz that shows us the number of customers by cohort and by period. And is that right? No, wrong period. We want to use this period. Okay, and so now you can see that that gives exactly the same value that we had in this viz, and which we have sense checked against the calcs that we did this way, and so we know that it's right. Cool? All right, I'll just show you, I have 6 minutes. I'll just show you an example of like what you could do with this. So another customer had wanted to calculate the 180-day rolling return rate. So what they wanted to see is for a given day, so let's pick the 27th of September 2013, they wanted to look back on the 180 days leading up to that and then find how many customers bought in that 180-day period of time. And then they wanted to see, of those customers, how many of them were repeat customers. So the purple line shows you repeat customers, while the blue line shows you total customers. And then the return rate is just showing you the ratio of those two things, which as it converges towards 100%. That's because we don't have any new customers. So this is something that is essentially what we're doing. What you need to do to create this kind of visualization is for every single day, do a count distinct query across the prior 180 days. So if we could just do this natively in Tableau, this viz would issue across 4 years something like 1,400 count distinct queries, which is insane. And that would definitely really hurt your database. And so this is a case where transforming the data allows you to do that. With the caveat that there's like 600,000 records behind this, built off of our 10,000 row Superstore data set. So just be aware that it does really increase the volume of data. So it might be more worthwhile to just stick to sort of simpler things that are looking at kind of rolling 3 period of time as opposed to 180 days. Just to give you an idea of what else you could do with this. So now to wrap up, I just want to give you guys like a quick kind of cheat sheet of like what are the things that you should be thinking about asking when you're trying to decide, is a problem easy or hard? Is it a table calc or is it a data prep problem? So the first one is, are the number of periods you're trying to compare bounded or unbounded? So you saw in that first example, if it's compare the first purchase date to the second purchase date, we can do it with LODs. But whereas if it's compare every interval across time, and I don't know how many intervals there are, then it's unbounded. So for bounded problems, we can use level of detail expressions or table calculations. For unbounded, we saw that LODs are not the way to do that, and so look at using table calcs or data prep. The next thing is we want to look at the level of detail of the viz. So are we comparing data that's actually inside the viz? For example, when we looked at the churn rate, we were looking at data that's in the viz. Or are we looking at data that's at a more granular level of detail? So for example, the inter-purchase frequency of customers, that's at a much more granular level of detail than the viz. So if it's in the viz, use table calcs. They're easy. That's what they're designed for. If it's at a lower level of detail, then you want to think about using either LOD expressions, if you can, or data prep, if you can't use LODs. So you'll see here that if you end up with a situation where you're trying to compare an unbounded number of periods of time at a lower level of detail than your visualization, that kind of corners you into doing data prep. The next thing to think about is whether you're analyzing change in measures or dimensions. So if you're looking at how is my sales changing over time, that's super easy. We can do that with calcs, we can do it with table calcs. It's quite trivial. But if you're looking at how is a dimension changing over time, so how is a customer changing over time, or how is a patient changing over time, or how is a student changing over time, or anything like that, that's a lot more complex than just looking at how a measure is changing over time. Another way to think about this is, should the output of your calculation be a measure or a dimension? So you remember when we dragged in the cohort, that's a dimension. It ends up slicing all of my customers into cohorts. So if the output of your calc is a dimension, that's another consideration to this point number 3. So if it's a measure, you can use table calcs or level of detail expressions. If it's a dimension, you can use level of detail expressions or data prep. One thing you probably noticed is that table calcs always return measures. So if you're trying to slice data by a table calc, that's really frustrating because it's a measure. And then the fourth thing to consider is, assuming you answered, you're analyzing changing dimensions to number 3, then the next thing to consider is whether you're analyzing a snapshot of that data, so what did it look like in 1 month, or whether you're analyzing a historical view of those changing dimensions. And if it's a snapshot, we can do that with level of detail expressions because we're comparing it to one single reference point in time. Whereas if it's a historical view, that's when you need to think about doing some data prep to generate records for missing events. So how much time do I have? I'm going to run over. You can leave if you have to. I have one final thing to say. So I know a lot of this stuff, you're probably thinking like, wow, this looks like really complicated and this is really hard. But just bear in mind that I have filtered out to the most edge cases that people see to deliver this session. And the last thing I want you to do is go away and be like, everything's a really complicated decision. So I want to show you just a really simple example of what most data prep looks like in Tableau. Okay, so this is back to my partner. This is the rotor of how to staff people in the hospital. And so these are night shifts, these are when they're off, and then this is the doctor. So one of the questions that he had was, is the staffing fair at the hospital, or am I working more night shifts than other people? So I want you to remember that the majority of data prep problems are not nearly as complicated as what I've just shown you, and they look like this. So if we grab that Excel file, there it is, the neurology and stroke rotor. So where is it? The live rotor. Most data prep is literally this simple. So I don't want you to go away and overthink things. We pivot these, and then we have doctors, and then we have shift type. And then we were able to see in 2 seconds how many days are being worked by different doctors. They're all working the same number of days, that's good. But by shift type, what does that look like? And these are the night shifts. Okay, and this right here is my boyfriend. So he's working less night shifts than anyone. And we were like, this is amazing. Let's not tell anyone about this, especially not this person who's doing the same job and working, a third or 50% more night shifts than he is. So remember this. Most things are simple. I've just wanted to give you guys kind of a framework for how to approach the edge cases and the more complex problems. So thank you very much for coming. If you want to attend sort of related sessions, I'm doing another session on cross-database joins, and it's all about sort of complex data structure problems that we can solve, really similar topic to this. If you want to do a hands-on session, there's a hands-on session on Jedi Calcs that talks you through what method to use based on the problem. And then if you want to look more into level of detail expressions, go to Lots of Fun with LOD expressions. So thanks very much for attending. If you can please fill out the session survey, that would be great. Thank you.